My name is Yogesh Kumar. I am working as assistant professor in Tagore College of Engineering in EXTC department. Here I am giving the brief idea about the basic components. In basic components, I am giving about the resistors, capacitors, diode, LED, transistors. In transistor, I am giving BJT and the MOSFET. So first of all, here we are giving the brief idea about the resistors and how to calculate the value of resistors. So this is the resistors. Resistors is the very basic components. It is used in any electronic circuit to divide the voltage or current or to attenuate the signal in electronics circuit. By using the color code, we can calculate the value of the resistor. This is the color coding of the resistors. Here this is the first band, second band, third band and fourth band. Fourth band indicates the multiplier and fifth band indicates the tolerance and the sixth band indicates the temperature coefficient. So in this resistors, first band is brown, second band is black, third band is black and fourth band is gold. So first band is brown. So in this case, brown indicates 1. First significant is 1. So here we are writing first band is brown, black, black and gold. So in brown indicates 1. So it 1. Black indicates 0. So 0. Again third band indicates black. So 0. Fourth band is gold. So we multiply by gold 10 raised to power minus 1. So 10 raised to power minus 1. So if we multiply, then it becomes 10 ohm. So value of the resistance is 10 ohm. So by using the color code, we can find the value of any resistance. So in this case, the value of resistance is 10 ohm. Now we move to the potentiometer. Potentiometer acts as a variable resistor. So we can calculate the value of resistor. We can change the value of resistors by using the potentiometer. See, in potentiometer there are 3 terminals. First terminal is called A, second terminal is called B and third terminal is called C, ABC terminal. So if we connect A and B, if we connect terminal A and terminal B, and so if we connect terminal A and B and we move in the anti-clockwise direction, then value of the resistor will be increases. So it increases from 0 to its maximum value. Here maximum value indicates is 47 kilo ohm. Its maximum value is 47 kilo ohm. So if we connect the terminal A and B and we move in the anti-clockwise direction, then its value increases from 0 to 47 kilo ohm. So here we are moving. First of all, it indicates minimum value. Now we move in the anti-clockwise direction. Now its value continuously increases, kilo ohm. Now its value increases continuously. Now it becomes maximum value. So if we move in the anti-clockwise direction, then its value will be increases. Now if we move in the clockwise direction, then its value decreases from maximum to minimum value. So now move in the clockwise direction, here moving in the clockwise direction, then its value will be decreases. So this is the terminal A and B. Now if we connect the terminal B and C, terminal B and C, now if we connect the terminal B and C, now if we move in the anti-clockwise direction, then its value will be decreases. So if we move in the, see this is the maximum value. Now if we move in the anti-clockwise direction, then its value will be decreases. And if we move in the clockwise direction, then its value will be increased. Just reciprocal of the dVs. Okay, so this is the potentiometer. Now we will introduce about the capacitor. There are three types of capacitor: polar capacitor, non-polar capacitor, and the variable capacitor. In polar capacitor, the positive terminal or the negative terminal is fixed. So, and in non-polar capacitor, we can use either terminal as a positive terminal and or negative terminal. So this is the polar capacitor. In polar capacitor, there are two terminals. One terminal is shorter than other terminal. So in this case, shorter terminal indicates negative and the longer terminal indicates the positive. And also there is the white strip. Here white strip indicates it is negative terminal. We have to connect to the negative, and longer terminal indicates the positive. The value of the polar capacitor is given on the capacitor. See, this is 470 microvolt. This is the value of the capacitor. This is the 25 volt. It means we can apply maximum up to 25 volt. We cannot apply more than 25 volt. Here indicates the temperature. Maximum temperature is 150 degrees centigrade. This is the polar capacitor. So we can calculate directly value of the polar capacitor. Now this is a non-polar capacitor. In non-polar capacitor, size of the both terminal is same. So we can use either one as a positive terminal or second is the negative terminal. Now we how to calculate the value of the non-polar capacitor. To calculate the value of the non-polar capacitor, this is given 100. This is given 100. So first 100. So first is 1, second is 0, third digit indicates multiply. If 0, then we multiply 10 raised to power 0. Means it is 10 picofarad. In second capacitor, in this case written as 104, means 1 0, and third terminal indicates 10 raised to power 4. This is 10 raised to 5 picofarad. This is 10 raised to 5 picofarad. 104 means 104 means 104 means 10 raised to 4. So 10 total 10 raised to 5 picofarad. So the value of this capacitor is 10 raised to 5 picofarad. So in this way we can calculate the value of the non-polar capacitor. Now the next our device is diode. Diode is the very basic semiconductor device. It is the combination of p-type semiconductor and n-type semiconductor. So this is the diode. This is the diode. In this diode, the white terminal, this is the white strip. White strip indicates the cathode, means we have to apply negative potential, and other terminal indicates anode, means we have to apply at the positive terminal. We have to apply positive terminal. So this in this way we can check, we can calculate the polarity of the diode. We can calculate the polarity of the diode. Second type of diode is the Zener diode. This is the Zener diode. In this case, strip is black. So black strip indicates negative terminal and other terminal indicates the positive terminal. So in this way we can calculate the polarity of diode. Now next device is the LED. LED. In LED there are two terminals. One terminal is longer than second terminal. So in this case shorter terminal indicates negative means we have to apply negative voltage, and longer terminal indicates the positive, means we have to apply positive voltage. So this is the diode. So we have to apply negative potential at the shorter terminal and positive voltage at the longer terminal. Next, we introduce transistors. There are two types of transistors, BJT and the MOSFET. So first of all, we introduce BJT. This is the BC547 transistor. We know transistor is the three-terminal device: emitter, base, and collector. So there is two surface. One is curved surface, and second is plane surface. If the plane surface facing towards myself, then the most right hand terminal is called emitter. See, this is the plane surface and facing towards myself, then the most right hand is emitter, middle is called base, and the last is called collector. So this is the right hand is called emitter, middle is called base, and left is called the collector terminal. Then we introduce about the MOSFET. MOSFET is the four-terminal device: source, drain, gate, and the body. So this is the notch in the MOSFET. This is the notch in the MOSFET. If we hold in this way and move in the anti-clockwise direction, then if we move in the anti-clockwise direction from the notch, then the first terminal is source, second terminal is called drain, third terminal is called gate, and the last terminal is called substrate terminal. So in this way we can recognize the terminal. In anti-clockwise direction, first terminal is source, second drain, third gate, and fourth is substrate. That's all.